All right, this is our test review number 1, the one that you already started yesterday. Okay, so let's check our answers. All right, for number 1, answer each of the following questions for the graph that's on the right. And then it says estimate the zeros. Now, if we have to remember, if we have to estimate the zeros, remember my zeros are my x-intercepts, they're my solutions. So if we look right here, one of my zeros is at about negative 1.5. Okay, now if we look right here, going through the origin, notice how it comes down, it barely touches it, and then it goes right back up. Remember, guys, that's one of our double zeros. So that means I'm going to have 2 zeros at 0. And then if we had to go one more time, we got another one right here. And we can say that's at about positive 1.5. Okay? So that graph actually has 4 zeros. It has a 0 at negative 1.5. It has a 0 at 0. It has another 0 at 0. And then it has one at positive 1.5. So what you just found were your x-intercepts. And those are going to be kind of our going off points. So let's go ahead and write those under x-intercepts. I've got one at negative 1.5, at 0, at 0, and then again at 1.5. Okay? Now, another easy one for us to find is my y-intercept. So my y-intercept is where it touches the y-axis, and if we look over here on our graph, it touches the y-axis on the origin. So the y value at the origin is at 0. So far, we haven't had to do anything except look at our graph and see where it touches the graph. Now, the one thing that I do want you to remember is that when your graph comes down and it touches the x-axis and then it goes right back up, it does not cross underneath it. That's when we're going to have a double zero. That's like it comes up, it taps it on the shoulder 2 times, and then it goes away. That's why we have 2 x-intercepts at 0. Okay, let's see what we can figure out here. Okay, my domain. If I'm talking domain, then I'm talking about all of my x values. Okay, so if I'm doing all of my x values, this graph, if I look at the ends, my ends are really arrows, which means my graph goes on and on forever. And like we talked about on the first day, for any polynomial graph, our domain will always be negative infinity to positive infinity. Or it's also fine if you just do the all real numbers sign. Either one. Now my range is my y values, but the one thing that people often forget is that we read the range from the bottom up. So bottoms up is an easy way to remember it. So if I start from the bottom, my graph is going down to negative infinity. So my range is going to be coming up from negative infinity, up, 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 all the way up until I get to the highest point on the y-axis, the point where it never gets higher than, it never gets taller than positive 1. So my range for that graph is going to be from negative infinity up to positive 1. So from negative infinity to positive 1. Lock it in. All right. Let's talk about increasing and decreasing. Okay, starting fresh. Okay, first thing I want you to do when we start talking about increasing and decreasing, I want you to draw a line through each one of the terms. Okay? I need you to draw a line through each one of the terms. Okay, I'm going to pick the color that we normally use. Let's go with green. All right, that works. All right, so let's draw a line straight down through here. Color didn't work. Okay, I know y'all shop. Down through that turn and down through this turn. All right. Notice I just drew a vertical line through each turn on the graph, and that separated my graph into 4 individual parts. Now, if we're talking about where it's increasing is where that graph is going to be going up. Okay, where that graph is going to be going up. So, notice my graph is my blue line. So, if I had a little guy walking on that ground, he's going to be increasing. He's going to be going uphill in this whole section from negative infinity until I get to this line. Well, what does this line go through? This line right here goes from negative infinity to right here, and its value is at -1. So I would say she's increasing from negative infinity to -1. And then we can lock that in. Okay. She's also increasing in this one little tiny little part right there. Increasing right there. So if we're increasing in that little part, from this line to this line, what are the values of those lines? Well, this line on the left is at the origin. So increasing from 0 to 1. So we would say that graph is increasing on the interval from 0 to 1. All right. Let me get all this out of our way. Let's start fresh. Because now we're going to talk about decreasing. We're talking about where it's going downhill. Let me go ahead and draw my lines first to help us out. Okay. And if we're talking decreasing, we're talking where that graph is going downhill. So it's going downhill right here in this little bitty part. And then it's going downhill on the big tail end over there. So whenever we start talking about where it's decreasing, we're going to have us one small interval from right here to here. And then we're going to have us a big old interval from right there. Okay? So we've got to figure out what are those numbers? What lines are those intervals between? Well, the first little tiny one, it goes from -1 to 0. So we would say decreasing from -1 to 0. Now for the big part where it's decreasing from +1, going on forever and ever and ever, to positive infinity. Now I know a lot of y'all are saying, but Miss Adams, that graph is going down. That graph is going way down. That graph's going to negative infinity. Why did you say it's decreasing to positive infinity? Well, that's because whenever we're talking about increasing and decreasing, we're talking about x values. We're talking about what x values between what numbers on the x-axis are they increasing and decreasing. The only thing that we need to worry about up and down is to tell us whether it's going uphill or downhill. No specific numbers. We're worried about what block on the x-axis. For example, what block on the x-axis was she first increasing? Well, she was increasing from negative infinity until -1. Anywhere in this interval right here, that graph's going to be going uphill. So we're not worried about the y values, we're worried about the x. let's talk about our maximums and minimums, because we know we got some stuff going on in this graph. First of all, looking at my arrows, they're pointing down. They go down forever, which means that graph is going down to negative infinity. So if that graph is going down to negative infinity, that means that there is not an absolute lowest point that that graph is ever going to meet. So that means there is no absolute minimum. Okay. So let's look right here, but I know you're saying, but hold on, Miss Adams. We got us an absolute minimum right here, don't we? With that one isn't the absolute lowest that graph can go. It is a low point, it is a valley, but it's not the absolute lowest. So this point right here at the origin, we're going to call that a relative. That's a relative minimum. So you've got a relative minimum at the point 0, 0. Okay, now let's talk about maximums. Let's talk about the highest this graph goes. If you look at this graph, there is a point on that graph that it will never ever get higher than. Your graph will never get higher than that right there. So if it never gets higher than that value of 1, then we're going to call that an absolute max. That's an absolute max. So we're going to say we've got 2 absolute maximums at -1, +1, and then again at 1, 1. Now, if you have an absolute max, that means we don't have a relative max because we're able to measure an absolute highest point. All right, moving on down. Talking about end behavior. As I look at this graph, my 2 arrows are pointing down. They are going toward negative infinity on both sides. So if we're talking about end behavior, well, both ends are pointing down, so both ends are approaching negative infinity. If we're talking about minimum degree, then that means we need to count how many terms are in that graph, how many times that graph changes direction, and then we need to add 1 to it. Okay, so let's count how many times that graph changes direction. It goes up, here's a turn. It goes down, here's a turn. It goes up, here's a turn. Okay, so that means I've got 3 turns. So 3 plus 1 means my minimum degree is going to be 4. Now, if my minimum degree is 4, it's even, right? And we know that even functions have to have an endpoints that go in the same direction, either both up or both down. Well, in this one, my endpoints are both going down. So if they're going down, if they're approaching negative infinity, then the sign of the leading coefficient must be a negative because they're going down. Now, if we're checking for symmetry, can you fold this across the y-axis? Can you fold it across the y-axis and it land on itself? Well, sure. If you fold that hot dog style, it would land right on top of itself. So we would say that this is even. It is symmetrical across the y-axis. All right, looking at number 2. Sketch the graph by hand, given that the zeros, remember zeros are your x-intercepts. So your zeros are at -3, -1, and 2. So 1, 2, 3. There's 1 0. -1. There's 1 0. 1, 2. There's my other 0. So I got 3 zeros. It says then answer each of the following questions for the graph. Okay? So now if I look right here, I know that no matter what, this is a polynomial. So I know every polynomial's domain is negative infinity, positive infinity. Always, always. It also gave me my 3 zeros, 1, 2, 3. So I know that my number of zeros is 3. So now all I got to do, okay, it's a cubic function, and it's a positive leading coefficient. So I know that odd numbered functions with a positive leading coefficient are going to have end behavior with 1 going down, and on the right it's going to be going up. Now, if I know that my degree is 3, remember, if I need to know my number of extrema when I know that the degree is 3, well, all I do is I take my degree, which is 3, subtract 1, and that means that I'm going to have 2 terms, which is the number of extrema. Same thing. So that means my graph is going to change direction 2 times. So that if I'm going to go up here, let's say it turns around, there's 1 turn, and there's the other turn. Now yours may not look exactly like that, but as long as you have about the right shape and it's going through those zeros, then you're fine. Now let's answer our end behavior questions over here. My end behavior, as my x is going towards infinity, as my x is moving to the right, what's my graph approaching? So as my x values are going out to the right, my y values are approaching positive infinity because it's going up in the air. As my x values are going out to the left, as they're going to negative infinity, my y values are falling down. They're going down, so it's approaching negative infinity. Now again, your graph may not look exactly like this, but as long as you have that general shape, your arrows are pointing in the correct direction, you've got 2 turns, and it goes through these zeros, you're good. That's why it's called a sketch. Okay, number 3, determine the end behavior and the maximum number of extrema. Okay, so first of all, I know that this has a degree of 5. So when I'm finding my extrema, all I do, okay, when I have an equation, when you know the equation and you know the degree, you do degree minus 1 equals 4. I've got 4 extrema. Now, I also know that this function is odd, and it's got a negative leading coefficient. So if it's odd and it's got a negative leading coefficient, first of all, I know that my arrows are going to be going in opposite directions. And I also know that if it's a negative leading coefficient, it's decreasing. So no matter what's going on in the middle, that doesn't matter. We're talking end behavior. So I know on the left, as x goes towards negative infinity, my graph is going straight up in the air. It's going to positive infinity. As I go out to the right, to positive infinity, my graph is falling down quickly. So it's going to negative infinity. Okay, let's check out this letter B. For letter B over here, I'm going to draw a line. Whoop, there. Okay, letter B. I've got to find my degree first. Remember, degree is the largest exponent. The largest exponent that I see here is what? I got 2x to the thirds, but I got me 1x to the 4. So there's my degree. And remember, for extrema, I say degree 4 minus 1. So it's going to be 3. Okay? This function, it's even. So I know that my ends are going to be going in the same direction. But now look at my leading coefficient. Leading coefficient is negative. Okay, so if I have a negative leading coefficient, that means that both of my ends are going to be pointing down. They're both going down. So that means that no matter what, on both sides, my ends are approaching negative infinity. Okay, even, odd, and neither. This is what we did yesterday. Remember, if it is odd, then it's got to have all odd exponents. If it is even, then it's going to have all even exponents. One thing we have to remember is if you have a constant, remember that little dog that was barking at us? If we have a constant, then that's really x to the 0. So looking at letter A, f of x equals x to the third, that's odd. Okay, looking at this one, negative 5x. What's my power that goes on that x? Well, that is an understood 1, so that's also odd. So if they're both odd, then that function is odd. Okay, letter B. I've got 2x squared plus 4x1 minus 6. Now this is my constant, and my constant is an x to the 0. So I've got me an even, I got me an odd. If I've got a mixture, if I've got an even and an even, but I got this odd, that means it's neither. My exponents have to either be all even or all odd. If they don't all match, then it's a no-go. Okay? State the range and the number of zeros for each of the following polynomials. The range and the number of zeros. Okay? Looking right here. If we graph this, you could type this in your table and you could graph exact points. Okay? Now I know it's negative because it's got my negative coefficient. I know it's got a degree of 2. So I know the general shape of this is going to be an upside down parabola. Okay? Now if I had to go ahead and graph that, if you were to plug in some values and make that graph, okay, if we do, okay, it's going to be shifted over. So it's going to go to the left 4. And my points, it's going to look like this guy. I'm sure yours looks a lot prettier, but it's fine. Okay, and this goes through the points, negative 4, 0. So the number of zeros for that polynomial, it comes up to 0, 0, and then it shoots right back down. This is a double 0. I know it's ugly graph and it's hard to see, but this is actually a double 0. It comes up and it goes down. So my number of zeros, I've got 2 zeros. Because I got a double 0. right there. Now, my range for this one, remember, range would go from bottoms up, so from negative infinity, is going to go up, 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 and the highest that it goes is, boom, 0. So my range is going to be from negative infinity to 0. Never gets higher than 0. Okay? Now, if I need to know how many zeros I've got, okay? Looking right here. Here's my graph. So if I go to my calculator, I make me a table. I do 3x to the third plus 4x minus 7. Okay, I'm going to be able to make me a little table here. So my x and y values, let's see, if I go to negative 1, I got negative 14. If I go to 0, I got negative 7. 1, 0. 2, 25. Okay, so it's getting up big and it's getting up quickly. Okay, so this graph, if I had to sketch it, negative 1, negative 14, that's way down here. 0, negative 7, that's about halfway, it's right there. 1, 0. 2, 25. Woo, it's going way on up there. Okay, so now this one is actually going to have some stuff going on. So it is cubic, right? So it's got to have 2 zeros. I'm missing some. I might need to go back in and make it a 0.5 that I'm counting by. Because I know since my degree is 3, I got to have me at least 2 zeros, right? Okay. So if we were to sketch this, regardless of where that other 0 is, it's probably like right here. If it were coming up and down and then up, okay, this is cubic, okay? Cubic tells me I gotta have me 3 zeros. The degree tells me how many zeros I got. So I know I gotta have 3 zeros. See, right here we have 2 zeros. So I had 2 zeros. Even though it was a double, I had 2. Here I got 3 zeros. So I know I got to have 3 zeros happening somewhere. Now, it asks me what's the range. Well, check out this graph. Even though it's ugly, going down, it's going to negative infinity. Going up, it's going to positive infinity. So the range for that graph, negative infinity to positive infinity. Okay. Big thing to take away from number 5. Degree tells me the number of zeros we're going to have. Big thing to take away from that. Okay, number 6, state the sign of the leading coefficient and the degree if the degree is even or odd. Okay, well, look right here. Going down, going down. Same direction. Okay, so I know it's got to be even. And if they're both going down, they're both pointing down, then the sign of the leading coefficient is negative. So I know it's even because both arrows are pointing in the same direction. So there's even. And since they're both pointing down, leading coefficient is negative. All right, letter B. On the left is pointing down, but on the right is pointing up. So odd is opposite. And then if I look though, I'm increasing. That graph is making a climb. Well, I mean, even though right there it's not necessarily increasing, but it's starting from the bottom, but it's going to end up way on up high, right? So if that graph is increasing, then that means we must have a positive leading coefficient. Okay, true or false? The domain of a polynomial function is always negative infinity to positive infinity. True. That is true. I don't care what your polynomial looks like, if it looks like this, if it looks like this. I don't care if it looks like this. It's still going to be a polynomial. Polynomials are always negative infinity to positive infinity. The range of a quadratic polynomial function is always negative infinity to positive infinity. Quadratic means my degree is 2, right? And the graph of a quadratic polynomial is either going to be a positive parabola or a negative parabola. Well, no matter what, either one of these parabolas is either going to have an absolute lowest or an absolute highest. It's either going to have a mountain or a valley. So if that's true, then my range is not going to be from negative to positive. This is false. Letter C. Cubic polynomials never have an absolute minimum or maximum. Cubic looks like this. Or if it's negative, it looks like this. Check out those ends. They're either approaching positive infinity or negative infinity. So if it's going to infinity, then I don't have any absolute minimums or maximums. That's true. And then letter D for a polynomial, it is possible to have a relative max and an absolute max. They're saying for a graph, it's possible to have both relative and absolute. What do we think? Okay, if we're talking relative max, that would be right here. The whole reason we have a relative max is because I can't tell you what this is going to. Okay? So my answer to that is false. Because we can't have both. We either have one or the other. Okay, what questions do we have? Raise your hand.